All right. Good morning. Warm-up problem here for ya, right from the start. Just want to know if that's a solution to that system. Back into thinking about solutions to systems. While you guys are doing that problem, let's talk a little bit about this week. Today we're gonna definitely pick it up a few notches. I figured out Emerald Lagasse to pick it up a notch. We'll see in the next line. And then tomorrow we'll keep bringing the heat, and then Friday will be a summative quiz. And then next week we'll start talking about matrices. And then looking at the 24th for your test. I think that's a Friday. Okay. Oh. So how do I go about figuring out if this is a solution or not? Replace x with 4 and y with 7. So if I look at the very first one, then that would be 3 times 4 plus 4 times 7. 3 times 4 is 12. 4 times 7 is 28. 12 plus 28 is 40. Is 40 equal to negative 17? No. So it fails there. So no, it is not a solution. In order for it to be a solution, it's got to work in all of them. If it fails in one of them, it is not a solution. Now, if you would have started with the second equation, it would have worked. Okay. 4 times 5 is 20, minus 7 times 10, so that's 7 times 10 is 70. 20 minus 70 is negative 50. It works in that one, and so then I'd have to, if you started with that one, then you got to go to the second equation, in this case, really the top equation, and check it there. It fails. You started with the one that failed, it just isn't. Okay? So, like I said, Emerald Lagasse, let's take it up a notch. Bam. Okay? So we're going to go to 3x3 systems of equations. So now what that means is we're going to have an ordered triple. It's not an ordered pair anymore because now I've got 3. I've got an X, I've got a Y, and I've got a Z. Again, an alphabetical order for that one. Okay. So is that ordered triple, 7, negative 1, negative 3, is that an ordered triple solution for this system? Done the exact same way. I'm going to replace X with 7. I'm going to replace Y with 1. I'm going to replace Z with negative 3. So in the very first one, we would have 2 times 7 plus 5 times 1 plus 3 times negative 3. 2 times 7 is 14. 5 times 1 is 5. 3 times negative 3 is negative 9. 14 plus 5 is 19. Minus 9 is 10. And 10 is equal to 10. So it checks out in the first one. Have to go to the second one to see if it works. 3 times 7 minus 1 plus 4 times negative 3. 3 times 7 is 21 minus 1. 4 times negative 3 is negative 12. 21 minus 1 is 20. Minus 12 is 8. 8 is equal to 8. Works out in the second one. Whoa. Thing moved on. I just want to do those. Okay. Now I've got to check it out in the last one. 5 times 7 minus 2 times 1 plus 7 times negative 3. 5 times 7 is 35. 2 times 1 is 2. 7 times negative 3 is negative 21. 35 minus 2 is 33. 33 minus 21 is 12. 12 is equal to 12. So yes, because it worked out in all 3 equations, it is a solution. Fails in 1, not a solution. And you're done with that problem. Okay? Works in 1, got to check the next one. Works in both, got to check the next one. Okay? Got to work in all of them for it to be a solution. It's got to fail in only 1 for it to not. Okay? How we go about finding those ordered triples, well, that's going to be the joy of today. The joy of today is going to be, we're going to solve a system of equations. There's 2 different methods for 3 by 3 that we know of so far. The first method is substitution. We learned that today. The second method is the elimination. We'll learn that tomorrow. Okay? So, if this were a 2-equation, 2-variable system of equations, and I said solve by substitution, what would your first step be? So from last week, isolate what? One of the variables, right? Now, that same step is going to be here. We're going to pick a variable and an equation, and we're going to solve it for that one. Okay? Doesn't matter which one. You have 3 choices in 3 equations now. So really, you have 9 different choices. Before, you only had 4. Now you've got 9 choices. Make it easy on yourself. There's 3 easy choices here. What are they? Bottom one for? Nope. Bottom one for X. What's another easy choice? Top one for Y. Middle one for Z. But you just said X, Y, and Z. All 3 of them have X, Y, and Z in it. You know what I mean? Okay, all right? Okay? So, top one for Y, middle one for Z, or bottom one for X. Doesn't matter to me. You guys pick. Top for Y? Okay? So we're going to solve this top equation now for Y. If I do that, I would get Y equals 10 minus 3x plus 2z. Agree with me on that? Okay. Last week, when we were doing substitution, what was our second step after we solved one of our equations for one of our variables? We substituted that variable. That step going to remain the same, except now you've got to substitute it into 2 equations. So this 10 minus 3x plus 2z is going to go in there for y, and it's going to go in there for y. It's got to go in both. So let's do the first one first. So we would have 6x minus 2 times our new y plus z equals negative 2. So that's going to be 6x minus 20 plus 6x minus 4z plus z equals negative 2. 12x minus 3z equals 18. Agree with that? Okay. Then we've got to do into the third equation, x plus 4 times that, and plus 3z is going to equal 7. And now this is 10 minus 3x plus 2z. Agree with that? Yeah. I'm going to pull out the old highlighter. What do you notice that you have now? Only x's and z's, right? Yeah. 2 equations, yes, with only 2 variables. So what can we do then? We could start over with either substitution or elimination or graphing, whichever one we want. Yeah. So now we're going to use substitution or elimination on those 2 new equations. What do we want to do? Substitution or elimination? Elimination. Okay. Which variable do we want to eliminate? X or z? What was that? Z. Okay. So if I'm going to eliminate z, that means I need to multiply the top equation by 11. 12 times 11. 132. 3 times 11. 18 times 11. What do you got? 198. I would have to multiply the bottom equation by 3.
when I add those two equations together, what do I get? (99x) equals 99. So what's x? 1. Okay. So if x is 1, which equation do you want to plug it back into? Top or bottom? Bottom one? Yeah. Adding 11. Dividing by 11. So now I'm at x is 1, z is 2. Now what do you think we should do? Which one? Just one of them, right? Okay. Yep. So we're going to plug those two now, into one of the original equations. Which original equation? I'm going to scroll. Actually, I won't, because I don't want to, get people sick on the interwebs. So my top equation was what? 3x plus y minus 2z equals 10. Okay, so that's going to be 3 times 1 plus y minus 2 times negative 2 equals 10. 3 plus y plus 4 equals 10. So y has got to be 3. Yes? Okay. What do you think step 5 is? We got to check our answer, because it would suck. Hold on, let me move this up. It would not be so nice if we did all of this work and then only to find out that we missed a negative sign or something like that, and we got all of it wrong. And then you're going to yell at me because you're like, oh, I did all that work. And I'm going to say, yeah, you missed this negative sign. Okay? Right? So, hold on 1 second. Okay? So if x is 1, then 3 times x is 3. If y is 3, then that's going to be plus 3. If z is negative 2, then negative 2 times negative 2 is positive 4. 3 plus 3 plus 4. 10. 10 is equal to 10. Checks out. If x is 1, then that's 6. If y is 3, minus 2 times 6 would be minus 6. And z would be negative 2, so that'd be plus negative 2. or just minus 2. 6 minus 6 minus 2. Negative 2. Checks out. If x is 1, that's 1. Y is 3, that's going to be plus 12. Z is negative 2, that's going to be minus 6. 1 plus 12 minus 6. 13 minus 6 is 7. Checks out. So it works out. Now what we have to do is we're going to write our final answer in ordered triple form. X, Y, Z, or ABC, or alphabetical order. But we write that in ordered triple form, alphabetical order. Questions on that? Okay. It's a lot of work. These are not like cram it into a corner type problems. Okay? These problems need space for you to show all your work so that you don't miss a negative sign or something like that. Okay? Go for it. So when I'm looking at this, I only see one choice for step number 1. Which equation, which variable? Last one for y, right? Again, you want to make that choice as easy on yourself as possible. Okay? So if I'm going to solve this equation for y, I would get 6x plus 4z plus 1 equals y. Yes? Okay? Now that has to go into the top equation. And the middle equation. All right. So this is going to be 4x plus 12x plus 8z plus 2 plus 3z equals 1. So that's 16x plus 11z equals negative 1. X minus 18x minus 12z minus 3 plus 5z is negative 14. That's going to be negative 16x minus 7z equals negative 11. Yes? Okay. Nice thing is that we can just straight up add those two equations together. It's going to give me 4z equals negative 12. Divide by 4 gives me z is negative 3. Let's go into this one.
get x is 2.
Okay. So probably going to plug it into this last one here then. So let's go with 6 times x minus y plus 4 times z equaling -1. Z is -3. X is 2. That gives me 12 minus y minus 12 equals -1. 12 minus 12 is 0, so that's -y equals -1. Divide everything by -1 or multiply everything by -1. Y equals 1. Okay? So if x is 2, then this is 8. If y is 1, then that is 2. And if z is -3, then that is -9. 8 plus 2 is 10, minus 9 is 1. Checks out in that one. If x is 2, then that is 4. If y is 1, then that's -3. If z is -3, then that's -15. 4 minus 3 is 1, minus 15 is -14. Checks out. If x is 2, then that is 12. Y is 1, then that's -1. If z is -3, then that's -12. 12 minus 1 minus 12 is -1. That one checks out. So my answer here then is going to be 2, 1, -3. Before you ask the question, I'll answer it. Yes, the order of those numbers matters. Okay? If you give me the answer here as 1, 2, -3, you are wrong. You're at a different point in space than where you're supposed to be. Okay?
These are a lot. Understand that's too fun. The whole page for one is.
I know. Okay? So on the blue sheet, back side, now you should be able to do the top 2. So you should be able to do all of the front side and the top 2 on the back side. We'll knock out the bottom 2 tomorrow.
I'm just migrating up